Okay, good morning. This is Professor David J. De Los Reyes. Okay, my topic for this morning will be trigonometry, and this will now be lesson number 14. It will be a long video format topic on trigonometry, and this will now be lesson number 14. Okay, let's proceed. The subject matter for this morning will be a continuation of my trigonometry complete syllabus subject matter, that is trigonometry lesson number 14. The title of the topic will be example problem on angle of depression. The last time around, I have given you an example problem on the angle of depression, but for this morning, it will be another variation of a problem, okay, concerning angle of variation. Okay, let's proceed. I will just give you the figure, then I would like to, okay, announce verbally how the problem will be coming out. Okay, we are given a cliff here, and this is the water surface. Okay, there is an observer at this location here. Maybe he got a transit observer. Then he says what he call this, a boat approaching the cliff. Okay, and he measured the angle of depression of the boat at this first location here. First location. The angle of depression is 30.33 degrees. Okay? After the boat advanced by a distance of 100 feet, the boat is advancing 100 feet towards the cliff, 100 feet. He observed that the angle of depression of the boat increased by 19 degrees in 18 minutes. Meaning to say this 30.33 increased by a value 19 degrees 18 minutes. Also supposed to be, it will increase because it's going nearer, right? So this angle here should be bigger. So the resulting angle of depression will be 49.63 degrees at the second location. First location, it's 30.33, the angle of depression. Second location, the angle of depression is 49.63. It increased by a value of 19 degrees 18 minutes. Okay, this is the height of the cliff. Okay. The problem is asking what will be the height of the cliff. Capital letter H equal to. Okay. Oh, that's the summary of the problem. An approaching boat, initially the angle of depression is 30.33 degrees. After advancing 100 feet, the resulting angle of depression increased by 19 degrees 18 minutes. It now become 49.63 degrees. The problem is asking how high is the cliff above the water level. So this is the cliff. This is the unknown height of the cliff. How high is it above the water level? Right? Okay, these are just my computations regarding the angle of depression. The initial angle of depression is 30 degrees 20 minutes. If we try to convert this to degrees, 20 divided by 63 will be 0.33. So this will now be 30.33 degrees. That's the initial angle of depression. The second angle of depression increased by 19 degrees 18 minutes. So initially, this is 30 and 20. We add 19 degrees in 18 minutes, and if we try to take the summation of this and converting it to decimal, it will be 49.63 degrees. So this is 49.63 degrees, 49.63 degrees, this is 30.33, this is 30.33. The problem is asking, find for capital letter H, the height of the cliff. How high is the cliff above the water level? Okay, let's try to bring out the solution. Oh, this is just an easy one. If you could visualize the problem. There are actually two right triangles. Okay, the first right triangle is actually the right triangle considering the observer and the boat, right? This right triangle here, the bigger one. Okay, the longer one. this is 100 feet, this is x, right? So the location of the boat with respect to the horizontal vertical line here will be x plus 100. So this is x plus 100. And this portion here is actually the unknown height of the cliff. That's x. This is the observer. Initially, this angle here is 30.33 degrees. Okay? If this is 30.33, this should also be 30.33. Okay? So we can remove this one now. So actually, we know this angle already. This is the boat, this is the observer, this is capital letter H, and this distance here is the the distance of the boat from the vertical line is actually x. It's represented by x. So this total length here is x plus 100. So there are two unknowns, h and x. Okay, let's try to take the tangent of 30.33. We are given the opposite side, adjacent side, considering 30.33 degrees. So the relation of h and this side here is actually tangent. So tangent of 30.33 degrees should be h over x plus 100, right? And if we try to compute for x, x will be h over tangent of 30.33 minus 100. We calculate this one now, so we eliminate tangent, right? We take tangent of 30.33, we take the reciprocal. What will come out will be 1.709h minus 100. We call this equation number 1. Right? There are two unknowns. X for the meantime is unknown. The height of the cliff for the meantime is unknown. So we are given a linear equation involving two unknowns, linear. Right? X as a function of h. That will be equation number 1. Okay, let's try to bring out the right triangle on the second location, considering the second location. The second location, this is the second location. The distance of the boat from the vertical line, considering the second location, is x. So this is x, right? And this is still h, the unknown height of the cliff. This is the observer, this is the boat. Initially, the angle of depression, actually, it increased, right? It became 49.63 degrees. So this is 49.63 degrees, right? So if this is 49.63, this should also be 49.63, and we can remove this one now. That's the angle of depression, same as this one. So considering this angle here, this should be opposite, this is adjacent. Again, the relation of h in terms of x will be tangent. So tangent of 49.63 degrees should be h over x, opposite over adjacent side. And solving for x, x now will be h all over this. And if we try to compute for the tangent of 49.63 greater than 45, so 1 all over greater than the tangent of an angle greater than 45 is more than 1. So if we try to divide this one, it's less than 1, because this is more than 1. So x now will be 0.85h, and we call this equation number 2. So we are given another linear equation involving h and h. Okay, under the study of algebra, two simultaneous linear equations, two unknowns. Okay, we can solve it. This is x, so we equate x equal to x using equation number 1. X using equation number 1 is this one. X using equation number 2 is this one. So we equate this value here to 0.85h. So 1.709h minus 100 equal to 0.85h. Okay, so after the equating, the only unknown now is actually h. We are now given a linear equation in one unknown, and that's an easy one already. We transpose this one to the left. We subtract that to 1.709. It will become 0.859, and we transpose this negative 100 to the right. It will now be 100. So h now will be 100 over 0.859, and the value of h is 116.41 feet. So the unknown height of the cliff is 116.41 feet. Okay, that's it, guys. This is a good example problem on the concept of angle of depression. Okay, I hope you understood my explanation. Good morning from Los Angeles. This is Professor David Jenner.